Hi everybody, can you hear me? Okay, yeah, that's good, it's mic'd. All right, so I'm Devika and I lead the Netflix messaging engineering and platform team. I'm gonna start today by giving you an overview of Netflix emails across the entire customer lifecycle. I'll go back in time and talk about some of the history and some of the challenges we had in the past and our motivation for using Amazon SES. And then I'll spend some time talking about how SES helped us with our challenges and our requirements and the actual transition to SES. So Netflix, the Netflix ecosystem, what can I say? There's a lot going on at any given point in time. There's many events occurring simultaneously. You have members signing up in different parts of the world. They're starting to stream on a variety of different devices, their laptops, mobile phones, tablets, PlayStations. At the same time, Netflix is adding a lot of content. We're bringing a lot of originals, we're adding licensed content. And as members stream, we learn about what they love, what they don't love, and the algorithms predict content for them to watch. And at the same time, it's possible, however, that some members aren't having such a great time. Maybe they forgot their password and they can't get in, or possibly we locked them out because we couldn't build them, so they can't stream anymore. Some members just might not be finding something interesting to watch, and so for some of these reasons, they might choose to cancel and leave Netflix. So the role of messaging is really to reach out at all these events with the right message to re-engage the members, to delight them, to close a loop, to unblock them, and in some cases acquire them and bring them back to Netflix. And that's really been what we've been doing through messaging for the last several years. We've done a lot of A/B testing. We A/B test everything we do at Netflix, and messaging is no exception. We're constantly optimizing our core metrics of retention as well as acquisition. And through that A/B testing, we've arrived at a very nice portfolio of messages and rich messaging experiences. And I'm going to talk through some of those next in detail now. So this is Netflix.com. This is where the sign-up experience begins. And if you see that red button, join free trial, try a free month, that's where most potential members click on to try Netflix. Next, they're taken to this screen where they pick a plan that they are interested in choosing. And after that, they're asked to put in an email address and password and create an account. What comes next is the request for a method of payment. And as you might imagine, many potential members drop off here. So they thought they would like to just try Netflix, and now they're like, oh, I have to put in my payment method, and so they drop off. And so what have we done here to bring them back? We've built a series of messages that we call the Remarketing series, designed to bring them back and finish the sign-up experience. And so some of the examples of the messages here are this one, where we're talking about, come and look at favorite shows. We're showcasing some content. We have the call to action button around starting the free trial. Another example here calls out more specifically different genres of content that we have available. And again, the call to action is start your free month. And then here's another example which has a more deeper or richer set of content that we're showcasing. We're also talking about the fact that you can watch Netflix on different devices. And so this experience starts after the potential member drops off, and it continues for a period of time. And we've A/B tested this for acquisition wins. However, since ISPs are constantly fine-tuning their algorithms and trying to learn more about messages and message senders, it's possible that because of the cadence, because of the regularity, because of the kinds of words we're using, there's some risk to deliverability of these messages to the actual inbox. And also some recipients tend to click on the spam button instead of unsubscribing from the actual email. And so in that case, that affects the reputation of the IPs being used to send these messages as well. So there's some risk to the deliverability of these messages. So going back to the sign-up flow, this is the scenario where the potential member actually moved forward, gave us the method of payment, and clicked on the Start Membership button. We've designed a series of messages to welcome the members to Netflix. And this is really to make them feel welcome and delighted and get them to get familiar with Netflix. We start with the sign-up confirmation message, which is essentially telling members about their plan, how much it's going to cost them when their free trial ends, what is the email address on file, and a pointer to get them started. And then after that, we start talking about features on Netflix. And so this includes things like, hey, you can catch Netflix on all your mobile devices. By the way, did you know we have a kids area, which is really great too. And there's a few other messages in these series that include things like the profile feature where everybody can set up, where you can have multiple profiles per account. We also talk about the My List feature. And so it's essentially getting everybody to get the most out of Netflix and learn how to use Netflix. We also have some messages that showcase some of the popular titles. Next, as members stream more, we learn more about them. We learn what they love. And so we're able to send personalized recommendations to them. And here's an example of a new arrival message. This is personalized for members based on what we think they would enjoy. Here's an example of a new season message that some of you also might have seen. This is sent to members who've seen prior seasons, and the algorithms predict that they really love them and they're going to enjoy the next season. And then we have a pre-promotion message for originals. Again, very targeted, very personalized, determined by algorithms. And so we do believe that because these are so relevant, the ISPs would deliver them to the inbox. And so there's low risk when it comes to deliverability. And we're not expecting complaints from this because these are messages that people really love. And again, we've done a lot of A/B testing to see that these drive streaming wins and retention wins. Now, for some sad reasons, people choose to leave the service and they cancel. And we, of course, want to bring them back. And so we've built a series of messages that we call the Rejoin series. And these messages, again, we're trying to talk about what's changed since they left. So this one is showcasing some new content that's been added. And of course, if the members are eligible for a new trial, we also talk about that in the call to action. Here's another example where we have a different presentation of the content. And here's another example where we're talking about one specific piece of content. And so different copy, different design, different images, different content, different subject lines to drive acquisition. And again, this is something that potentially, because has a cadence, has some terms that might be free trial and driven to drive sign up, they might result in slightly low deliverability from an ISP standpoint. To recap, it's emails across the entire customer lifecycle. So we have acquisition messages, then we have messages to drive engagement when we get the members to sign up. We also do transactional messaging to close the loop on transactions that members are doing in the site. And then if they happen to cancel, we send them messages that are intended to get them to rejoin. So a quick note about transactional messages. We have examples. An example here is the password reset message. And this happens very often when when members have forgotten their password. And it's something that they request. And it's actually really important because otherwise they can't do anything. They can't stream. They can't get in. We also have other confirmation of transactions, such as members changing their plan, changing their method of payment, members changing their password and email address. And this is essential to make sure that we are closing the loop as quickly as possible and providing an accurate view of the latest state of the member. All these messages also have different patterns. So as you can imagine, the transactional messages and the acquisition and rejoin messages, which closely mirror the signups and the cancel rates, have a well understood trend and pattern. The peaks and the troughs and the daily volumes are well understood. That being said, the engagement messages are the most unpredictable. And that's because they're a function of what is the new content that's coming on the site based on the deals that the Beverly Hills team has signed and when these contracts and shows are going to go live, as well as what members have been doing and what the algorithms are predicting for them. So it can be anything on any given day, and it's something that really changes and really depends. So really quick, again, a recap of the different classes of messages. We have the member transactional messages. We have the other messages to members, the most important being the personalized engagement messages. And then we have the non-member and the former member messages. And as I talked through earlier, the chances of not being delivered from the ISP are very low for the transactional messages and the other member engagement messages. But the non-member and former member messages, there's some risk that the ISPs won't deliver them. So I'm going to go back in time to to a place when Netflix had moved a lot of its core services out of the data center into AWS, and that was the big move to the cloud. All the microservices were in the cloud. And what did it mean for the messaging platform? So the messaging platform, i.e. the core message processor, these are the components and the services that generate millions of emails, millions of messages per day by talking to all the other microservices in the Netflix ecosystem, as represented in the orange boxes here, had moved into AWS. And we had moved these into the different AWS regions, US West 2, US East 1, EU West 1. That being said, the actual delivery of the messages to the ISPs was being done in the data center, and we had our own IT team that was running our own servers with the email delivery software. And we had to hop over and connect to this one data center to actually send out the messages. So clearly, as you can see, it's a single point of failure, and it wasn't elastic. There was pre-provisioned capacity in the data center, and it was what we had, and we were basically just using that. So it wasn't a very easy to scale model, right? It was nice to see that the message processors, the orange boxes, would scale up and down based on the needs of the day. If you had to send 5 million or 30 million or 80 million messages, that's all elastic. That works great. But we had fixed capacity in one data center that was doing the actual sending of the messages, right? So there are other challenges other than just not being elastic and not being available in multiple regions. We had to keep these servers running, this email delivery software running in the data center. And it wasn't just about running it. It was also about optimizing the settings for the ISPs. So I remember we were configuring the limits in terms of number of connections, max number of connections concurrently that would be open to a given ISP, the number of messages per connection, the number of messages per unit of time. And it became a very specialized piece of everybody's work to kind of understand how these things came together to get great inbox deliverability and to reduce the number of bounces. Speaking of bounces, this is essentially what happens when the email address is invalid and the ISPs actually reject the emails, right? And there are soft bounces, which are other reasons for why the emails don't go through because the servers are having some temporary problems. But all this bounce status was being logged on these different servers, and our team had to parse those logs, rotate those logs, and then take that information and go and mark the email addresses as bad so that we wouldn't go back and try to resend to these bad email addresses. The other piece that was important was what we call the complaint feedback loop. And what that is as I mentioned earlier, sometimes recipients just mark emails as spam. And that, we don't know that they're doing that because they're not clicking on the unsubscribe link in the email. So getting that feedback so that we can actually unsubscribe on their behalf is something that needs to be set up with the different ISPs. And so we had to work with a third-party vendor to set that up for us. And then we had to process that through a separate process. And so we had these different paradigms of consuming bounces, a different system that worked with feedback. We had the software running, a lot of specialized information. It wasn't elastic. And so we kind of felt like this. I don't know, we were like, this is not working. We got to do something about it. And so we started looking at some other options as far as how can we build a system that is simpler to operate, that is elastic, and that lets us move faster and let us do what is core to our business. And that's where we started exploring other options. But first what we did was recapped the requirements for Netflix email so that we could evaluate the different options, the different solutions against these requirements, right? So first and foremost, great deliverability for 100 million and more messages a day. We knew that we were going to be adding a lot more countries. We were going to go live all over the world. We were going to add more subscribers, and we would add more content. And that means we would just be messaging more to get people more engaged and to get them more excited and to drive our metrics. And so not only did we need great deliverability, we also needed a system that could scale linearly at cost with the global subscriber growth. We also wanted to have multi-region delivery of transactional messages. And What that means is, the important messages that users are sitting waiting for, like the password reset message or something that confirms what they're doing on Netflix, is very important and has higher SLAs. And since Netflix has strategically chosen to have presence in multiple regions, as I showed you in the slide earlier, we wanted to be able to do the same. And this was so that we could have great experience in different regions and handle a situation when one region was completely unavailable, and so everything was being served out of one region. So we had to be able to support that use case to be able to send the transactional mails from different regions, from every single region. And we wanted to isolate the risk for different types of messages. We didn't want the deliverability of the non-member and the former member messages, which were designed to bring people back to sign up, to impact the deliverability of the transactional messages and the messages that are important from an engagement standpoint. And bottom line, we wanted to simplify operations. We didn't want to be doing something that was not core to what the product was about, what messaging was about. And we wanted to leverage other expertise when it comes to really knowing how to deliver emails with great reliability. And so that's where SES came in. And really, we knew, of course, that SES would be great in terms of being elastic. We would pay as we went along. It would be wonderful to not have to worry about tweaking and optimizing the settings with the ISPs and not having to manage that infrastructure and not have to have pre-provisioned fixed capacity. So that was great. And we also had some other requirements, which we worked with Amazon, SES, to move towards. And so first and foremost, the most important requirement, as I showed you earlier, was great deliverability. And what's the biggest thing around deliverability is IP reputation. So we wanted the ISPs to trust our IPs that were used for sending emails. And the way we would do that is by making sure that we had dedicated IPs that other customers of Amazon weren't using. So we worked with the beta dedicated IP program with SES. And we set up, furthermore, 3 specific pools for risk isolation. So that was the other requirement that we had to make sure that the deliverability of the non-member and former member messages didn't impact the deliverability of the important transactional messages. And so as you can see here, we have 3 pools, the transactional pool on top, the member pool at the bottom, and the non-member former pool at the very bottom. And how we accomplished this was the message processor, which is a system that's actually assembling and creating these messages, would get metadata from the metadata service about where to route any particular message. So every message in our system has metadata, which helps route to the right pool for delivery. And behind the scenes, we also had different quotas and different throughputs for each of these different pools so that could meet our different requirements for these different kinds of messages. Multi-region presence, so we had SES resources available in the different regions that Netflix had presence in, and our message processors were present in. And so we built the accounts, we set up the accounts to be able to use SES in the different regions so that we could send the transactional messages across different regions, in every single region. And this was really great from our ongoing operations perspective. I mentioned earlier that we had separate processes for looking at bounces, we had separate processes for looking at feedback, and it was a lot of extra work, and we were really happy that through SES we were able to get feedback through SNS about actual delivery, about the bounces, as well as the complaints. We integrated with that feedback API, and we took the data and graphed that using some of our internal graphing systems. And so we had real-time insight into what was happening with our email delivery. And you can see here we were also able to plot the latency to make sure that the numbers were in line with our SLAs. So once those 3 things were done, right, the dedicated IPs were set up. We had the 3 pools set up for risk isolation. We integrated with SES in the different regions, and we built this feedback. We were now ready to start transitioning some of our email sending out of the data center to SES. And so that's what we did next. And we gradually started ramping up and sending a little bit of traffic in every region through SES. We were warming up the IPs, right? That means that we were really trying to get the ISPs to understand the kind of traffic that Netflix would be sending from these IPs. And as we did that, we looked at the bounces, we looked at the feedback in terms of the delivered status and the complaints, and we looked at the latency to measure against what we had with our existing infrastructure. Two other things that we looked at. The first thing was IP reputation, right? So we work with a third-party vendor called Return Path. And they have infrastructure that gets them insights about the reputation of a given IP address. And so we were able to look at the different IP addresses that were in our dedicated pools and see what reputation this tool was giving them based on a combination of a lot of different factors. And we wanted to make sure that we had great reputation because great reputation drives great deliverability. And the second thing we looked at as we were in this transition phase, as we were moving traffic over from the data center to SES, was actual inbox deliverability, right? So clearly, you send a message to Gmail or Yahoo, and you can get a bounce back. That means they rejected it. But sometimes when they accept it, it also doesn't make its way into the inbox, right? And so it might land up in the spam box, and so spam folder. And so this tool gave us visibility into what was actually happening with regard to the emails actually getting delivered all the way into the inbox. And the way they do it is they have what they call seed email addresses, and these are email addresses that they own across a lot of different ISPs all over the world. We integrate these seed email addresses when we're sending emails out, and then they are able to track whether the emails make it all the way to the inbox, right, or whether they're kind of in the spam folder. And so you can see these percentages here, the 99, 98, are actually representing the inbox percentage rate, which was high. So these were really important. All these things were important to look at. Again, to recap, so we would increase the traffic to SES, we would monitor the bounces, the reputation, the inbox deliverability, and they would increase some more. And we kept doing this until we ramped up to a great percentage of our traffic, and we felt really good that we were at par or actually better than our previous solution, which we had in the data center. And finally, we severed all the ties to our data center and moved all the traffic to SES. So that was the story. I'm going to hand over to Kadir to talk more about the details of setting up through SES and the features that SES offers in more detail. And we can talk more later.
Thank you, Devika. Like Devika mentioned, how they transferred from their on-site premise to use SES. Now we are going to talk about how they actually did it by breaking them down. Before we go in, I want to reiterate the challenges with sending emails. To recap, getting the email delivered is hard, and you need to listen to the feedback, and managing that with multiple ISPs is complex as well. And you guys are great at what you do. It's like you build products, and you don't have to worry about the undifferentiated hard work of scaling up the emails and doing all the day-to-day maintenance of it. SES eliminates these challenges for you. And delivering emails, before we go into the details, delivering emails is a shared responsibility. We will help you with building all the infrastructure, making it scalable, doing all the hard work for you. But we also expect you to follow the best practices and send high-quality emails. That's a shared responsibility for sending emails. And how we do it, we provide you high deliverability. Before the email sends out, we scan the emails for spam and malware, and we don't send those emails to the ISPs before it touches our outgoing mailbox. And because of that, ISPs receive very high quality emails from us, and they trust us as a valued sender. That increases the deliverability for you. And SES maintains compliant feedback loop with major ISPs. We give that to you, which we will see in detail in some fine granularity about compliance, the bounces, and also the delivered metrics. And we expect you to send emails at a reasonable pattern, but also if you have one-time events or if you want to scale up and send more, you don't have to worry about it. You keep sending, and we will take care of that for you. And Amazon SES is built on the the trusted websites that runs Amazon retail, and you don't have to worry about us available for you to send emails. And we have better features which we will go into details today on how you can leverage to send the email sending programs. Before we go in, let's start with the fundamentals of email sending program. First, let's start with the setting up email authentication. When you authenticate an email, that gives a signal to your ISPs that you are a trusted sender and you are going to send trusted email. That builds up the reputation for your domain and also for the IPs that we use, that's a shared IPs, which we will go into detail on how that works later. And because of that, your deliverability increases with the ISPs. Before you start, we want you to verify the address or the domain on SES. We ask you to do that because we want to verify that you are the person who owns the domain or the address, and you can send emails. That helps us ensure high deliverability to everyone, and it also protects our recipient's inbox as well. And it's easy to verify. On Amazon SES console, type in your email, and then you will get an email with a link. Click on that email, and then the address is automatically verified for you. And you can also verify the domain that sends that email as well. All we ask you to do is add the DNS text record, and then you will get we will automatically detect that for you, and then you are ready to send from that email. Now that we have verified the email address or a domain, there's optionally you can use domain key identified mail, also known as DKIM. It's an optional standard that will allow you to sign the email messages. ISPs use a signature to verify that the messages are legitimate and no one has modified the message in transit. An email message that is sent with DKIM has a DKIM signature in the header that contains a cryptographic signature of the representation of the message, the entire message. And ISPs receiving that message can decode the decrypted message with a public key that is present in your DNS record to ensure that the message is authentic. Like I said, it's optional, but when you sign it, the DKIM compliant ISPs will look at you favorably, and then they will ensure that it builds up your reputation for you. And it's pretty easy to set up. From the Amazon SES console, we will give you 3 CNAME record, which you had to add to your DNS. And we will automatically detect it for you, and we will send you a notification once we detect that. And on that email, go back to the Amazon SES console, and then enable it. You are ready to send DKIM emails, DKIM signed emails. So we have verified the email of the domain, which is must for Amazon SES, and then we set up DKIM. And there is a third optional standard which we recommend you to do add as well, which is called Sender Policy Framework, SPF record. So SPF record is to designed to combat email spoofing. SPF record indicates as the ISPs that you have authorized Amazon SES to send email on your behalf. So when an ISP receives that email, they will check the sending mail server versus the domain that's in the mail from address, and then they will check whether they are the same. And if they are the same, then you pass the DKIM record, and then they will follow take actions on the email accordingly. With Amazon SES, you can do it in 2 different ways. Number one is, if you use the default mail from address, which is amazonses.com, you don't have to do anything because the mail server that's sending is Amazon SES, and also the domain that is in the mail from address is also amazonses.com. So you're automatically verified for SES. But if you want to use your own custom mail from address, then we ask you to publish the SPF record for you on your DNS record. So we have set up the email. This is a key. And before we go into more details on how you can get the compliant feedback loop and take a look at the dedicated IPs, I want to give you a few more feedbacks to ensure that you're ready for sending as well. Number one is the mailbox simulator, that's an underrated feature in SES. So what it does is, we have a mailbox simulator that will enable you to test your email sending and make sure that you are scaled up to send emails. And we also ask you to use HTTP instead of SMTP, because SMTP is a very chatty protocol. If you want to send one mail, you need to have multiple handshakes back and forth to send one email. But if you use HTTP, it's one response for one email sent. And you can also send in parallel. But going back into mailbox simulator, what it is it's a set of email addresses that will simulate a specific behavior for you. So we have multiple email address that will simulate successful acceptance, bounce, which is hard bounce, and we also give you soft bounce when we have multiple tries and if it fails as well. And you can use this to make sure that you all scaled up. And also one other tip is make sure that you are sending the actual email. Don't send hello world to the mailbox simulator, because that will not stimulate the actual sending. We ask you to send it with the actual email size, so you know that you are scaled up from your end. And also use this opportunity to make sure that the feedback loop is also scaled up as well. And with the feedback loop, why do we want to process feedback? Before we go in, let me give background on what they are and what we call as feedback loop. They're all metrics. So when you send email, you get delivered emails or bounce or complaints. You call it metric, we call that feedback loop. It's all the same. So the key metrics you want to look at is delivered, bounce, and complaints. Delivered is when we hand it over to the mailbox provider, you will receive a metric that's delivered. And if you send it to a dead inbox, that means it's a bounce. And if your recipient presses the spam button, then that's a complaint. You will receive those metrics from it. Acting on bounce and complaint metrics is really important, because when you send to a dead inbox, that signals the ISPs that your list is not current, or you have bought the list, or it's not up to date, and that you are not processing the bounce. So because of that, they don't look at you favorably. So we ask you to listen to these bounce emails and then process them, so you don't send emails to them again. And also with complaints, that means when someone presses the spam button, that means they don't like that content or they think that's not relevant for them. So we ask you not to send emails back to them as well. And it improves our customer experience, which is your customers or your recipients are getting the relevant email from your business. So before November, we had only one way to get the feedback notifications. So through SNS or through email, we send bounce, delivered, and compliant metrics across your entire AWS account. And what we have learned from our customers is, in multiple instances, there are small campaigns with bad list or bad content that undermines the whole reputation for your account. So with the feedback notifications we had, it was very hard to get that level of granularity to find out which campaign is not performing well, because we were giving it to the entire account. So we introduced a new feature called Event Publish. So with this feature, you can get very fine-grained metrics. I'm going to talk a little bit more about the new feature that we have launched, so you know how you can do that as well. So how it works is, we ask you to create a segment or configuration set. Each configuration set is customizable, and you can specify where to publish and which events to publish. Say, for example, there is this website called Amazon. Apparently, they sell everything. So if you are Amazon, if you want to use this, right? So you can use it by categorizing with multiple things like books and music. And you can further go down as well, and you can say, within music, you can create a configuration set called music, and then you can track them by genre and artist as well. So we give you that fine-grained granularity. And you can publish those metrics to Amazon CloudWatch or Amazon Kinesis Firehose. And you can, so this is a sample one I took from, before we launched this feature, we did an experiment, and this is a sample. You get this level of granularity for one of the segments we had. So creating a configuration set is pretty easy. So from the Amazon SES console, you had to create a configuration set and select a destination. And there are two destinations. One is CloudWatch. With CloudWatch, you need to create the CloudWatch dimensions. Select the event types you want to track for the configuration set, and then create the tags. For example, we had a generic one called campaign. And then we also allow you to set a default value as well. When you don't send any name value pair, SES will use the default value here. And the other option is the Firehose destination. For Firehose, you need to specify the name of the stream, and then the SES will assume to publish the event on your Firehose stream. So we talked about two different configuration sets. One is two different destinations, CloudWatch and also Firehose. You might want to know which one is better or what you want to choose, right? So Amazon CloudWatch is great for aggregated metrics. You can use it to get 5-minute or 10-minute aggregated metrics for your campaigns. But with Kinesis Firehose, you will get each and every individual events. And from Kinesis Firehose, you can stream them into S3, Amazon Kinesis Analytics, or Amazon Redshift, or Elasticsearch service clusters. And you will get it as a JSON object that you can intercept and you can interpret. The trick with this is, one of the things you can do on top of this is use Lambda to trigger workflows. So both CloudWatch and Firehose they do support Lambda. So it opens up a lot of possibilities for you. So you can set it up to say, if the bounds metric gets up to this threshold, start this workflow or kick this workflow. So you can start doing that from this. So this enables a lot of workflows for you, and then a lot of possibilities that you can be more proactive with your email sending. And Devika talked about dedicated IPs. Like Superman said, right? Or is it Spider-Man? Yeah, Spider-Man said, with great power comes great responsibility, right? That's dedicated IP. It's very powerful. It enables you to maintain your own reputation, but it requires a lot of commitment and discipline. Before we go into dedicated IPs, let's talk about how it used to work with Amazon SES. All of our Amazon SES customers send emails from a single IP addresses. What that means is, company A and company B could be using the same email address. And each and every email will have a dedicated IP address associated with it when it goes out. And because of that, the ISPs cannot differentiate between company A and company B. If you have one bad actor, that could undermine the reputation for the whole IP. And because it's shared between multiple companies, everyone is responsible for the reputation of the IP address. So it was easy to lose a reputation, and you might get affected of someone's bad sending habit. So that's where the dedicated IPs comes in. Dedicated IPs are static IPs that are dedicated just for your sending alone. So what that means is only you can send emails from that dedicated IP. And since no one else can send emails through that IP, you are responsible for the reputation of that particular IP. And from Netflix, we saw how they segregated different types of emails, and then how they build reputation for those emails. So with this, you can look at controlling your segments, controlling your different type of email, and then create high deliverability for your emails as well. You can have high, low, and medium priority pools, and then you can send that. And also, there are multiple scenarios as well. It's not just for reputation management, but also for whitelisting purposes. So if you want to whitelist your emails coming from your IP with your associates, you can do that. Or you can say, this is for operational email, DevOps email, and then every other email should be dropped. You can do that by whitelisting the IP. And because only you will be sending through that IP, you can use it to whitelist. So with dedicated IPs, your IP reputation will be ultimately driven by your sending practice, right? Since you guys are sending high quality emails and to a list that is more relevant, we don't have to talk more about that. One of the other key things is gradual warm up. I wouldn't stress because stress enough on this. When ISP sees a bunch of emails coming from a new IP, then they will think you are spamming their customers. So we ask you to gradually warm up the IPs. So start small and measure the results. When you measure the results, make sure that you are getting favorable results. And then if there are any bad results coming from, adjust that and then make corrections and send more. So you are ramping up for the sending, and then gradually warm up. So you are up to you are making sure that you are sending to your peak volume. But with dedicated IPs, there are a couple of drawbacks. It's great, but also a couple of drawbacks with that is you need to keep the IPs warm. If your business has this pattern of sending once a month email or once in a few days or once a week email, dedicated IPs might not be the right choice for you, because with dedicated IPs, to maintain the reputation and to keep it warm, we call it warm, the reputation, you need to have a consistent email sending pattern. Maybe it's not the whole peak load, but you want to keep sending it at a consistent rate. And also, you are responsible for estimating any potential increase. With dedicated IP, it's kind of, yes, we take care of all the scaling, the elasticity for you, but then each IP, you need to make sure that you are warmed up for you are scaled up for your peak volume. So that's another drawback with dedicated IPs as well. Like Superman said, it's a great power, but it's a lot of responsibilities as well. And we released this feature 2 weeks ago, and a few of our customers were in beta, including Netflix, but it's available for everyone as of last week. And thank you. We'll be off the stage for any questions for you guys, and please do remember to complete your evaluations.